Hello everyone. In this tutorial, we will see how much memory do our variables actually occupy in our RAM. Okay, so let's start. So what we know till now is that suppose we have a program like this, our compiler will convert this to a sequence of zeros and ones, right? Or the machine code, or the machine code. Now, do you know what are these zeros and ones actually? They are called bits. Either of 0 or 1 is a single bit. Now these two numbers, okay, or bits, what we know as bits, they are building blocks of how memory is being allocated for any of our variables. Okay, they are the building blocks. Now what is a byte? I think you all know about kilobyte, megabyte, gigabyte, terabyte, these form of data, right? So we will see how they are derived. So first see that, okay, what is 1 byte? So 1 byte is equal to 8 bits. A sequence of 8 bits. We have, let's say, 8 slots. Any of the slot can have value 0 or 1. Either is allowed. And when there is a sequence of 8 bits, we call a combination of 8 bits as 1 byte. Correct? Let's move ahead. Now next comes, what is 1 kilobyte or 1 KB? This is equal to 1024 bytes or 2 to the power 10 bytes. Getting my point? Next, what is 1 MB megabyte? This will come to be equal to 1024 kilobytes. Okay. Now what is 1 gigabyte? In terms of GB, we measure our RAMs, right? How much GB of RAM do we have in our PC or computers or laptops? So 1 GB is equal to 1024 megabyte. Right? Now what is 1 terabyte? This is equal to 1024 gigabyte of data. So this is how we do the conversion, right? Or we represent any of the bigger form of data, let it be megabyte or gigabyte, in terms of its smaller one. Okay, I hope this point is clear. Now how much memory I require to declare any integer variable, let's say x or y. Okay, so let's try to calculate that. So I have some functionality called size of. Okay, you can do one thing, you can either give the variable, okay, or you can give direct int. Okay, both will work in your case. So let me try with int directly, that if I have an integer variable or a variable of type int, then how much memory is being allocated for that inside our RAM by our compiler. Let's see that. So let me try running this. Okay, so we can see that something called as 4 has been printed. What is this 4? So 4 has been given here in terms of bytes, 4 bytes. So if I have any integer variable, let's say x or y, so after compilation, what will happen? For this, memory will be allocated in my RAM that worth how much? 4 bytes, or that costs 4 bytes. Okay, let's go ahead and see a bit more with other kind of variables. So for better clarity, let me just print a string here. Memory, let it be memory occupied by int is this much of what bytes, let's say. This is done. Okay, finally, and let me apply that for some other entities as well. So let me now try that first for float. How much float occupies? Let me change it here. from int to float. Now I will go for double. Okay, let me first print these three things. Fine. Okay. So you can see that integer occupies 4 bytes. If we have a floating variable, that also occupies 4 bytes. If we have a double variable, that occupies 8 bytes. Double of that, integer and float. Right? That's fine. Now let us go ahead for character. Paste it rather. If I have a variable of type char, then how much memory does it require? Fine. Let me try printing this. Okay, so you can see that for storing a character or any variable that has a data type of char, it requires only 1 byte. Right? Hope this point is clear to all of you. Now see, some points I would like to discuss is, we have an integer, right? We have a variable, let's say a of data type integer or int. There is a range of value it can hold. Not every integral value it can hold, right? That's not allowed. What is the range? So for any variable that is of type integer, it can hold data from -2 to the power 32 till, sorry, it's not 2 to the power 32, but an integer variable can range from -2 to the power 31 till 2 to the power 31 minus 1. This is the range in which any integer variable can lie. Fine. Now, let me show you another kind of variable, that is long. Okay. Okay, so let me wipe this out and just I will keep one print statement, and inside this I will keep something called long. Okay, we have another data type that is called long. Okay, fine. So long as well holds how much? 4 bytes. Another kind of data type is long. Okay. Now you can see that this long occupies 8 bytes. Fine. What's the difference we have between long and integer? We'll see that. So see, what happens is that if I utilize something called long, it takes 8 bytes of memory, right? But I am able to store integers in much broader range. From where to where? -2 to the power 63 till 2 to the power 63 minus 1. This is the range in which if I declare any long variable, long L, let's say, then this entire range can be fit into my this variable. Whatever numbers lies here, so I can store them inside the variable L. That's an advantage of long. Much broader range can fit there. So if you have bigger calculations, right, much bigger numbers are coming to you, you can utilize long instead of int there. Okay. As far as we proceed, we will see these examples. Moreover, the long we have seen. So in terms of range, it doesn't have any difference with the int variables. Fine. Now in this video, we have seen that one difference between our float and double is in terms of memory. A float variable requires how much? 4 bytes of memory, while a double variable requires 8 bytes of memory. More differences, more specific differences we will see in the next video. So thanks for your time. If you like, please like, share and subscribe.